Hello, my name is Keaton Adams. I'm a data engineer with Pivotal. This presentation discusses the use of the Filespace and Tablespace features of Greenplum Database to take advantage of multi-tiered storage in a Greenplum cluster. In a traditional Greenplum database cluster, segment servers are configured with a number of disk drives, generally in two RAID groups, mounted as Data 1 and Data 2, where the primary and mirror segment directories reside. All database objects such as tables and indexes are stored in the segment directories. In addition, all temporary files created during the query operations are written to these same two file systems. For most users, having all database segment server read and write activity managed by these two file systems works well. In this standard configuration, with all available data disks on a server configured as two RAID groups, there really has not been much of a need to use the Greenplum Filespace and Tablespace features. So what's changed? As technology continues to advance, there has been considerable improvements and innovations made to servers that allow for much more flexible and powerful Greenplum database configurations. Take, for example, the Dell PowerEdge R940, which can manage terabytes of RAM, has 4 CPU sockets to provision a very large number of Intel CPU cores, can be configured with a combination of traditional hard disk drives and newer solid-state disks, in addition to being configured with up to 12 non-volatile Memory Express, or NVMe, drives. The drive expansion and overall multi-tiered disk configuration can go even further by adding a Dell PowerVault MD3460 storage unit, capable of housing up to 60 drives of varying types and sizes. In this case, it is possible to configure the database to use different file system groups for different purposes. For example, if your ETL process is very change data capture heavy, requiring a high rate of IOPS, Filespaces and Tablespaces can be used to segregate those related table data objects to a fast SSD-based ETL disk staging area. Standard 1.8 terabyte 10K RPM drives in a RAID 5 or a RAID 10 configuration can be mounted as more traditional data directories to house the bulk of the primary and mirror database segment information. Larger capacity but lower performing drives could be used to create a data storage area for historical data that is queried infrequently, but still needs to be online and available to the users for information gathering purposes. Finally, temporary files can be redirected to alternate storage areas for fast data access and processing. So what about Greenplum Database in the cloud? Well, as it turns out, public cloud providers such as Amazon offer a number of tiered storage options that can be configured on a virtual machine. Using Filespaces and Tablespaces, it would be possible, for example, to create table and index groups in throughput optimized EBS volumes for traditional datasets, while using provisioned IOPS SSDs for temporary files and potentially ETL work. For longer-term retention of data in Greenplum internal tables, one could consider using Amazon's cold storage hard disk drive option. In Greenplum, physical volumes are allocated as a file space. This is the physical location on a disk where database object, data, and index pages are stored. At the logical database level, a file space is then mapped to a table space. A table space becomes part of the logical object definition in Greenplum. To create a file space, use the GP Filespace utility. At creation time, the administrator supplies a name for the file space and a physical path for the master, primary, and mirror database segments to use for database object storage. Once created across the cluster, the administrator then creates a logical table space that maps to the previously created file space. From there, the table space name can be used when creating objects such as tables and indexes in the database. For this demo, a 3-node Greenplum cluster was created in Amazon. The servers were configured with both throughput optimized and cold hard disk drive EBS volumes. The throughput optimized EBS volumes are used for the standard Data 1 and Data 2 file systems. The cold hard disk EBS volume is used for the historical file system, where I will create a user-defined file space. To create a file space across the cluster, I use the GP Filespace utility. I give a name for this file space, a data directory for the primary segments, a data directory for the mirror segments, and finally, a directory for the master segment. With the information provided, the GP Filespace utility creates a GP Filespace configuration file for the history data file system. I rerun the GP Filespace utility, this time passing in the configuration file that was generated in the previous step. Once the file space has been successfully created, I can then use it to define database objects. To use the newly created file space, I create a logical table space in the database that maps to it. Any object that supports the tablespace clause can now be located in the history data file space. In this example, both the customer table and the related index are stored in the history data tablespace. Once I create my database objects, I can use the system catalog tables to verify that both my customer table and my customer index are located in the history data tablespace. So what impact do file spaces and tablespaces have on the Greenplum parallel backup and restore operations? With file spaces and tablespaces defined, you run GP cron dump against a logical database like you would normally. The backup file set that is created remains the same, where individual dump files are created for each database segment in the database. On the master node, part of the dump output includes the schema create file. When you look at both the initial schema create file and the post data file, you will see that the default table space for the customer table and the customer index is set to history data. During a restore operation, any named table spaces in use must have the corresponding physical file spaces available on the Greenplum cluster. In this example, the backup set will be restored to an alternate logical database in the same cluster. The restore operation is successful as it creates the customer table and index in the history data tablespace. Finally, it is important to understand a key difference in a GP expand operation when file spaces and table spaces are used on the Greenplum cluster. To initiate a GP expand, the command is run with a file that contains the list of new database segment hosts, along with the logical database that will be used to store the expansion schema. This step does not change when there are defined file spaces and table spaces. The first pass of the GP expand will create the expand input file as usual. In addition, a second file with the .fs extension is also created in the same directory, which contains the file space expansion information needed by the GP expand utility. Before the actual expansion process is run, ensure that any underlying physical volumes required by file spaces exist on all of the new data segment hosts, such as the historical file system as used in this example. The two generated expand input files will have all of the definitions necessary to create the new database segments and the corresponding file spaces on the new segment hosts. To learn more about Pivotal Greenplum, file spaces, and table spaces, refer to the documentation available at the links below. Thank you.